So this is part two of matrix equation A times vector x equals vector b. So let's continue off. So in this example, it says determine if the columns of the matrix span are four. So what does that really mean? We need exactly four pivots, and we need a pivot in each row. So question is, do the columns produce enough pivots that we need? Do the columns produce enough? Need? Okay, so how many columns do we have? One, two, three, four. Okay, so we have to do convert it to we have to augment this. So we're gonna rewrite this matrix as five, six, and then we have to do our EF form. We have to convert it to our EF row echelon form. So uh, to save you enough time, so save us time. I already did the work, but basically this five becomes a one, then this all becomes zero, and then this eight, this negative eight becomes a one, and then top and bottom becomes zero, and then from this negative nine becomes a one, and then everything below the one would be zeros. And here, let me show you. But so when I did all the work, I'm not going to show you uh the exact uh order of operation because you can do it on your own. But when I did it, I get one, zero, 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 and then this would be a number, this would be a number, this would be a number, and then this would be a zero. Okay, so we only have three pivots, but we need four. So the columns of the matrix does not span R4. So since we have three pivots, one, two, three, we should have four. This, if this zero was a one, it maybe would have worked. But since we have three pivots, so no. Okay, let's continue. So on this example, it says write the augmented matrix for the linear system that corresponds to the matrix equation A times vector x equals vector b. Then solve the system and write the solution as a vector. Okay, so we have matrix A, this, and vector b. So what our goal is to somehow get vector x equals to augmented A, B. That's our goal. So let's first write it as an augmented matrix. So it would be 1, -3, 0, 2, -1, 5, 1, 2, 3, and then equals to vector b, which is 0, 1, -1. Okay, so we have to get our pivots. So let's make -3 into a 0. So how do I do that? I'm going to multiply 3 times row 1 plus row 2, and that will eventually give us your new row 2. So you can pause the video and do the work, but I already did the work, and you get 0, 5, 5, and then this would be 1. And then we didn't mess with row 2 or 3, so it's going to be 1, 2, 1, 0. And then this is going to be 0, 5, 3, -1. Then what I would do next is what would I do next? I would now get this 5 into a 0. So how would I do that? I would have to multiply -1 row 2 plus row 3, and that will give us your new row 3. You need to pause the video to do the work. Go ahead. I already got the work, and I get 0, 0, -2, and then this is going to be -2, and then this stays the same. Okay, and then now what I would do next is I guess we can get our pivots. So maybe we can make this -1 into 1 immediately. So how would I do that is I would have to, so that's right, 3. I have to multiply that by -1/2, right? This would be 0, 0, and then this now will become 1. And then this would be 1 now. And then this would be 0, 5, 5, 1. And then this would be 5, 0, 0, 3. Okay, next, what I would do is, what would I do next? Maybe make this 5 into a 0. So how would I do that is I would have to do -5 row 3 plus row 2. And that will give us your new row 2. 0, 5, 0. And this is -4. This is 5, 0, 0, 3, 0, 0, 1, and 1. Okay, and then maybe let's make these 5s into 1, so that's pretty simple. All you got to do is multiply it by a scalar. So let's start with this 5 right here. Let's make that into 1. So to do so, you're going to have to multiply the entire row 1 by 1/5. And I could do more than one scalar at a time. So now let's make this 5 into a 1. So I would have to multiply 1/5 row 2 into row 2. We get 1, 0, 0. And then this would be 3/5 now. And then this is going to be 0, 0. And then this is -4/5. And then this is going to be 0, 0, 1. And then this would be 1. Okay, so now this is column x1, this is column x2, and this is column x3. So now it is possible, it is consistent. So you could say x1, I mean x3, right? x3 equals to 1. And then you can also say x2 equals to -4/5. And then x1 is 3/5. Okay, and then you can write it as a vector. You could say x1, x2, x3 equals to 3/5, -4/5, and 1. So yeah, that wraps up for this lecture. We'll start a new lecture in the next video. So I will stop here. Thank you.